The application problems for compound interest are only difficult if we let them be difficult. Let's look at this first problem here. Adriana wishes to take out an installment loan to finance the purchase of a sailplane costing $248,000. Her loan requires a 25% down payment and equal monthly payments of $3,613.22 for 60 months. What is the amount of the finance charge for this loan? All right, so let's figure this problem out here. She has to pay 25% down, so the amount that she's going to finance, if the total was $248,000, that was the 100%, she's going to finance 75% of it. How much is 75%? Well, let's use our calculator to calculate that. Cross multiply and divide. Oops. We're going to take 248,000 times 75 divided by 100, and we get 186,000 is what it's going to finance. Okay, she pays $3,613.22 for 60 months. So she pays let's see if I can get both of those at the same time. $216,793.20. So the question is, how much did she finance? Well, we would take the $216,793.20 and subtract the $186,000 that she financed to find that her finance charges were $30,793.20. Next one. Alex wishes to take out an installment loan to finance the purchase of a lawnmower costing $479. Her loan requires a 30% down payment and equal monthly payments of $28.72 for 12 months. This is the same kind of a problem. We would first of all have to calculate the amount that is financed. 479 is the 100%. That's the total. The amount financed is only 70% of that, since it's a 30% down. Cross multiply and divide there. 479 times 70% is $335.30. $335.30. Okay, her payments are $28.72 for 12 months, which is $344.64. Subtract the $335.30, and we find that she financed $9.34. So that's how you do these problems. Let's look at the other kind of problems that we're going to be doing. The next section is a pretty easy question about the lottery. You just won $300,000 in a lottery. After taxes, you're only left with $210,000, which is still a lot of money, which you deposit in a savings plan earning 5.8% compounded monthly. If you want to live off the interest without drawing on any other principal, what amount can you withdraw at the end of each month? In other words, all we're looking for is the interest in this particular problem. Interest is principal times rate times time, or 210,000 times the rate, 0.058, times 12 of a year. In other words, how much interest will we have each month? That's how much we can withdraw each month. $210,000 times 0.058 times, I'm going to use the fraction key, 1 12th, and we find we can withdraw $1,015 a month. So we probably wouldn't be able to live off each month, but it would be a good supplement while we got something, a better job, I guess you would say. Next one. You plan on retiring. That's something we can look forward to with your account balance at $100,000. You want the money to last 25 years. If you earn 4.5% compounded monthly, how much can you withdraw each month? This problem differs from the last one in that the last one we didn't want to use up any of the principal. This time we do want to use up the principal. So let's go back to Excel, and we can use Excel to calculate for this problem. We are looking for how much can you withdraw each month. In other words, we're looking for the payment that we can make. Well, now that we know what we're looking for, we can use Excel to solve our problem. 0.045 is the interest rate, but it's per month. The number of periods is 25 years times 12 months. It starts out now with $300,000, and we don't want any left at the end, so we can withdraw $1,667.50. Next one. You want to accumulate $18,000 to take a trip around the world in 4 years. You can earn 5.4% compounded monthly. What amount must you deposit today in one lump sum to reach your goal? So this time we are looking for the present value, because that's how much we need to deposit today. That's the clue for it being present value. The rate is 0.054, compounded monthly, and it's going to be 4 years from now, 4 years of months. We aren't putting any money in per month, but we want to end up with $18,000 when we're done. So we need to put in $14,510.26 today. What amount could Uncle Ted deposit today? So we're looking for present value, so that the plan would have $12,000 in 5 years. Same kind of problem as the one we just got done with, equals present value. The clue here is today. The rate is 0.048 month quarterly, so divided by 4. Number of periods is 5 years times 4 quarters in a year. No amount is deposited each month, but we know we want to end up with $12,000 in 5 years. And so we would have to deposit $9,453.03 today. A dentist wishes to be able to purchase $19,000 worth of equipment in 4 years. What size of monthly payment, so we're looking for payment this time, equals PMT, that would enable her to make the purchase at 4.1% compounded interest compounded monthly. 0.041 monthly. The number of periods is 4 years monthlies. And right now, it doesn't have any money, but she wants to have $19,000 in those 4 years, so she has to deposit how much today, or each month? She has to deposit $364.94. If you have any questions, these are the compound interest application problems.